This is the humidity video with Mrs. Leonard. You've probably seen humidity and you never even realized that before. If you've ever seen water forming on windows like this, or if you've ever gone outside where there's grass and you've seen dew, as in Mountain Dew, uh, this is dew on the ground. These things are actually caused by humidity, and today that's what you're going to learn about. I just want you guys to know I miss you all. It's not the same, obviously, teaching from my desk at home, but here I am. I hope you have found a space at home where you can work. Maybe you are sharing it with your family members. If you haven't yet, create a schedule for yourself and write it down when you're going to do science, English, math, etc. When you're going to chat with your friends online, when you're going to work out, all that stuff. If you create a schedule for yourself, you're going to feel more in control of the situation, like you actually have power over this awful situation that we're all in. I have a feeling we're going to probably be in this for a lot longer. All right, let's dive into your lesson for this week. So remember that you should be recording these notes on a sheet of notebook paper, anything that is on the screen. And if I tell you to write something down, you should do that too, because you're going to need to refer back to that when you do the practice problems. And you are also going to need your Earth Science reference tables today, page 12. And remember, if this video is going too fast for you, you can always stop, rewind. That way you can always catch everything. Rewatch is the button that you want to click. All right, so humidity is how much water vapor is in the air. And remember, we've talked about water vapor before. We know that this is a gas, right? It's invisible. We can't see it. And sometimes we call this humidity, sometimes we call it relative humidity, which is measured as a percent. So just like you would measure your grade in class in terms of a percent, the highest is always 100% and the lowest would be a 0%. There's never going to be a negative percent. For example, if you're outside and you tell your neighbor or your friend, wow, hey, it really feels humid outside, what that really means is that there's a lot of water vapor molecules in the air. So that's a day, for example, where it might be 95% humidity. It's going to feel really, really humid. Sticky is another word that sometimes people use. And if there's not a lot of water vapor in the air, for example, over here where we have 10% humidity, these little water vapor molecules, there's not that many of them. And so that is going to be a pretty dry day, right? Humidity tends to make us feel sticky, or sometimes it can really mess around with your hair. Some people, their hair goes flat, and some people, their hair goes frizzy. So humidity can really play a big role in how we feel when we go outside. Okay, here's your first check for understanding. What is humidity? Hopefully you got that right. It should have been how much water vapor is in the air. A lot of people get confused and confuse humidity and temperature. Temperature is how hot or cold it is, and that is different from how much water vapor, how humid it is outside. You can have a really cold, humid day, or you can have a really hot, humid day, or you can have a cold, dry day, or a warm, dry day, right? So humidity and temperature are two different things. That's important to understand. All right, here is your second check for understanding. What are the highest and lowest possible percentages that the humidity can be? Hopefully you got that one. Highest should have been 100%, the lowest 0%. Remember, humidity can never be a negative number. Okay. So another thing that's related to humidity and relative humidity is something called the dew point temperature. Now the dew point temperature, you might have seen this on your weather apps and maybe wondered what it was. It's kind of an imaginary temperature. It's this imaginary temperature where water vapor in the air condenses. And if you remember, to condense means when the water vapor as a gas, turns into liquid water, okay? And you've heard this word before when we did our water cycle unit. That's when you have the water vapor in the air turning into little liquid water droplets, and that forms a cloud. But sometimes you can get a cloud when you reach the dew point temperature. And sometimes you get things like dew on the ground right here, or sometimes it can be frost if it's frozen dew. So the dew point temperature is a temperature, it's an imaginary temperature. And if the actual air temperature reaches that dew point temperature, that's when you get a cloud, or that's when you get dew, or that's when you get this water droplets on your window. Okay. So it might be a little bit confusing. Let me clarify that a little bit. So generally what happens is when the dew point temperature equals the air temperature, the humidity is 100%, the highest it can be. So when those two temperatures are exactly the same, you're going to have a really, really humid day outside. For example, if the dew point temperature is 45 degrees Fahrenheit and the air temperature is also 45 degrees Fahrenheit, then the humidity outside is going to be 100%. So one of the things that I always look at when I'm getting ready for the day is, well, except for now when we're all in quarantine, but usually when I'm going outside, I look to see what the dew point temperature is. Because if the dew point temperature is really close to this air temperature, then I know it's going to be wet outside. It's going to be sticky. It's going to make for a really bad hair day for me because the water vapor in the air is going to condense. And I just want to make sure that I'm prepared for that, right? Also, if it's 100% humidity, it is very likely either raining or maybe even snowing, right? Or if it's a really hot day outside, it might just be really, really sticky and humid. Or if it's not raining or snowing outside and it's not really sticky, there's probably dew on the ground. And for you and I in the city, that might not mean anything, having this dew on the ground, because maybe you don't have any grass where you live. But if you live out in the country or farther away from the city and you do have to go out on the grass, for example, my dad always goes outside to get the paper, and inevitably the paper is somewhere out on the lawn because the paper boy has missed the front door and he has to go out on the lawn to get it. And on days where the humidity is 100% in the morning, he gets so mad because there's dew on the ground and he goes out in his socks. So his new socks get all wet because the water vapor in the air has condensed on the grass. And that's where that water is coming from. It's condensing from the air, right? Now, in the wintertime, the frost that we get on our windows on really, really cold mornings, although we didn't really see that much this year, if the temperature outside is colder than the freezing point, water freezes at 32 degrees Fahrenheit, then that dew is going to freeze. And so the frost that's on these windows is just frozen dew. And again, all that means is that the humidity is probably 100%. So we measure humidity with an instrument that is called a psychrometer. The P is silent, so we don't pronounce that. So it's psychrometer. Okay. That psychro part, psychrometer, means cold or to cool off. And that kind of makes sense because one of these thermometers, a psychrometer is really just two thermometers. Here's one thermometer, here's another thermometer. One of these thermometers has a little wet cloth around it. Sometimes they call it a sock. And that cools the thermometer down, not because there's cold water on it, but because it cools down because of evaporation. And I'll get to that in a second. This other thermometer, we call it a dry bulb thermometer, but it's just a regular thermometer. We call it a dry bulb thermometer because it doesn't have a wet cloth around the bulb. That bulb is where the temperature is measured, okay? And then this handle here is where you hold the psychrometer. You just hold it above your head and you spin it around carefully. And then that way the wind hits both thermometers. When the wind hits the dry bulb thermometer, nothing really happens. It's going to measure the temperature no matter whether the wind is blowing past it or not. But this wet little cloth around the wet bulb thermometer is going to start to evaporate. The water that's on that cloth is going to start to evaporate. And that process of evaporation actually cools down that wet bulb thermometer. Yes, evaporation cools you down. You know this. You stand in front of the fan in our classroom and you get cooler That's because you have moisture in your skin, and that moisture is evaporating. And it's even more cooling if you sweat. That's actually why you sweat. The little beads of water on your skin form when you're overheated. And then when you have air that blows past you, that cools you off. Makes sense, right? Our bodies are pretty cool. So if the air is pretty dry, if we have a really low relative humidity, I'm going to call it low RH, that means that the air is really dry. Then that means a lot of evaporation is going to happen because there's not a lot of water vapor in the air, right? So the wet bulb thermometer is going to get really low, right? It's going to cool off a lot more, a lot faster. But if the air is really humid, in other words, if we have a really high relative humidity, that means that the air is really moist, right? It's already full of water vapor. Then that means there's not a lot of water, or I'm sorry, the water is not going to evaporate very much off of that wet bulb thermometer. And so our wet bulb temperature is going to be a lot higher. It's probably going to be really close to, or maybe even equal to, the dry bulb temperature. All right, last few things that you should know. The dew point temperature is almost always colder than the air temperature, or sometimes they're exactly the same. The point here is that the dew point temperature will never be warmer than the air temperature. So the air temp is always going to be the higher temperature. The dew point is always going to be the lower temperature, okay? Something else that tends to confuse students is they think that the dew point temperature is the same as the wet bulb. They are different. So the dew point, remember, is an imaginary temperature. The wet bulb temperature is an actual temperature. You're measuring it with that little thermometer that has the little wet cloth on it, okay? And finally, there is a difference between two instruments that measure humidity. We talked about a psychrometer. This is a picture of a hygrometer. A hygrometer is just another word for an instrument that measures humidity, but generally it stays in place and it can look like this. You can still see right down here, this is the little container of water that is keeping this little cloth right here wet. So this one is probably the wet bulb thermometer, and then this one is the dry bulb thermometer. Or it could just be a digital instruments that just tells you the humidity is 73% today, or whatever. A psychrometer, on the other hand, is something that you actually have to sling around. You have to spin it around. I'm going to link right here so that you can see a video of somebody using a psychrometer. Okay, check your understanding. What is dew point temperature? All right, hopefully you got that right. Remember, it is the temperature where water vapor, gas water vapor, turns into liquid water. I always think of this as the dew point temperature is the point at which dew forms, right? So that's an easy way to think of that. Here's another check for your understanding. Which one of these temperatures is the dew point temperature, and which one of these is the air temperature? Okay, so if you said 64 was the air temp, you were right. Remember, the air temperature is always going to be hotter. The dew point is always going to be colder than the air temperature. All right, you are going to need your Earth Science reference tables, at least page 12. Link right here to the Earth Science reference tables if you need to print that out. If you can't print it out, at least bring it up on another page on your phone so that you can kind of flip back and forth between those two. And on this page, the top table is the dew point chart. It even tells you that right here up at the top. And the bottom chart is the relative humidity chart. Sorry, I got that in the way, right? So this is your relative humidity chart. And these work exactly the same way. It's just that the dew point tells you what that dew point temperature is in degrees Celsius. It even gives you the units there. And the relative humidity chart tells you what the humidity is in percent. And it tells you the units right there as well. So how do you determine the humidity and the dew point using these charts? You definitely want to record these steps in your notes. There's only 4 of them because you're going to want to refer to them later. So step 1, determine the dry and the wet bulb temperatures. Now on this psychrometer, or hygrometer, I guess since it's staying put, the dry bulb temperature is here on the left, and it goes all the way up here. So if this is 20 and this is 30, 1, 2, 3, 4, 5 lines, and there's 10 degrees apart, so 10 degrees divided by 5 is 2. So these are going up by 2s, which means this dry bulb is 22 degrees. Doesn't tell me here, but I know it's probably degrees Celsius. I think I just have it cut off there on my screen. Okay, and over here we have to figure out the wet bulb temperature on the right hand side. Same thing is going up by 2s. So if this is 10, this is 20, this is probably 12. So the wet bulb temperature is 12 degrees Celsius. Step 2, find the dry bulb temperature on your chart. So we are going to try and figure out the dew point temperature, and then remember the relative humidity works exactly the same. Okay, so up here in the upper left hand corner it says dry bulb temperature, so that means all of these numbers here are the dry bulb temperatures. The dry bulb temperature in that psychrometer that I had on the previous slide was 22 degrees Celsius, so that means this right here is where I'm looking. Step 3, find the difference at the top. So if you look here at the top, it says this is the difference between the wet bulb and the dry bulb temperatures. This is important. Difference. It says difference. In order to figure out the difference, you have to subtract the dry bulb minus the wet bulb. In my example, it was 22 degrees for the dry bulb minus 12 degrees for the wet bulb, which means my difference is going to be 10 degrees Celsius. So I'm going to look up 10 degrees Celsius up here, okay? I cannot stress this enough. Do you know how many students miss this up all the time? Because guess what they look up here? Instead of looking up the difference, they automatically look up the wet bulb temperature. I'm telling you, it's going to happen to you. You just got to be careful, okay? So we're not looking up 12. 12 is the wet bulb temperature. That's not what we're looking up because that's not what this says. All these numbers up here are the difference between the wet and the dry bulb temperature. So that's why we're looking up 10 degrees. You have to subtract to find that. I'm stressing that a lot because this is the #1 mistake students make. And I know that you're going to make this mistake. Hopefully you won't. Hopefully you will all get this. That's my hope and wish for you. Okay, last step. Step number 4, you're following the numbers until they meet. So we said that the difference was 10. The dry bulb temperature is 22. And all I'm going to do is follow 10 down, and I'm going to follow 22 across. And where they meet, the answer is 3. 3 what? I come up here to the top. I'm trying to find my dew point temperature, so it's 3 degrees Celsius. And that's my answer. Instead, if you were asked to find the relative humidity, you just go down to the bottom table and you use the relative humidity chart. The only difference is that when you follow 10 straight down and you follow 22 straight across, your answer is going to be different. This time it's going to be 27, and it's not degrees Celsius this time because the units for relative humidity are percent. So your answer would be 27%. All right, give you a chance to try this on your own. What is the dew point temperature if the dry bulb is 16 degrees Celsius and the wet bulb is 10 degrees Celsius? All right, hopefully you got that right. Our dry bulb temperature was 16. Our wet bulb temperature was 10. If you followed 10 straight down, which was not what you were supposed to do, you might have gotten it wrong. You might have said -10. But that's not right. Because remember, you have to subtract 16 minus 10, which would be 6. 6 is my difference. So I have to follow 6 straight down, and that's how I ended up getting for my answer. It's how I ended up getting 4 degrees Celsius. Now, if you said 45 or 14, you probably used the wrong chart. So maybe you used the relative humidity chart instead, where you found 16, you followed it over, you did the 6 correctly, you subtracted correctly, but then when you went down, you got 45. And so if you got to be careful and make sure that you're using the correct chart. Also, if you forgot to subtract and you used 10, even though that was your wet bulb temperature and not what you were supposed to do, but if you followed that down, you might have gotten 14. So these are the most common mistakes that students make. So these are always going to be the multiple choice questions that you are given. So just be careful about that and pay attention. You got this. Let's try another one. What is the relative humidity if the dry bulb is 24 degrees Celsius and the wet bulb is 14 degrees Celsius? All right, for this one, hopefully you got that right. Remember, you had to take the dry bulb, which was 24, and subtract 14, which was your wet bulb. Here's my dry bulb. 4 minus 4 is 0, 2 minus 1 is 1. So I have to look up 10. That is my difference. Here's 10. Dry bulb is 24, so I come over here to dry bulb. There's 24. Follow that straight across. Follow the 10 straight down, and you should have ended up with 30% are the units. If you made the mistake to look up 14 for this number up here, which you should not have done, but if you did make that mistake and you followed that down, that's probably why you got 9%. And again, if you got 6% or negative 10%, you probably used the wrong chart. You probably used the dew point chart instead of the relative humidity chart. So again, practice makes perfect with all of these things. You'll get better with more practice. And I'll make an optional video if you still need some more practice with these before you try the actual Google form with the practice questions on them. And finally, the last thing you're going to learn here, we're going to connect this back to our lovely little station models. Remember these? This is on page 13 in your reference tables at the bottom. And the dew point is always going to be in the lower left-hand corner, always in the lower left-hand corner. So this number right here is going to be our dew point temperature, because over here, if we look, on our explanation, it tells us that the dew point is always right here. Remember that there are never any units on our station models. This is our station model right here. This is just the explanation. So even though the dew point temperature is in degrees Fahrenheit, over here we're never put degrees Fahrenheit, right? So on this station model, the dew point temperature would be 82 degrees Fahrenheit. Now, relative humidity is not stated specifically on a station model. Nowhere on here will you see anything about relative humidity. But there are a few things that you can look for that will help you understand what the humidity is. For example, if the temperature is the same or equal to the dew point temperature, then that means you have a high humidity. If they're equal, the humidity is 100%. If they're really close together, like these two, 83 and 82, really close together, then the humidity is probably like 98 or 99%. Same thing down here, 28 and 27. The humidity is probably pretty high, like above 90% is what I would guess for anything that's like only a degree apart, okay? If the temperature and the dew point are really far apart, then that probably means you have a low humidity, okay? So another thing that you can look for is whether or not there's a lot of cloud cover. So how much of the circle is filled in tells you how much cloud cover there is, right? Since 75% of this circle is filled in down here, then we would say that the amount of cloud cover is 75%, meaning I would call that like mostly cloudy, right? As opposed to this one up here, which is just cloudy, like all clouds, no blue sky at all. Sometimes you can see something that would be like this. That would be 50% cloudy, right? So like a partly cloudy day. And then sometimes you might see something like this. That would be 25% cloudy, right? So you just like a little bit of clouds, right? The more cloudy it is, then you have a better chance of it being a higher humidity, a higher relative humidity. The less cloudy it is, like down here, then you're going to have a low humidity. You can also even have a completely blank circle, And that would mean that there's 0% cloud cover, and that's like really low humidity, right? No clouds in the sky at all, so there's probably not very much water vapor in the air. Although you're not going to see 0% humidity anywhere on the planet. The lowest the humidity gets anywhere on our planet is about 20%. Even in the driest deserts, that's considered very dry, okay? And then the last little hint that I usually look for to tell me what the humidity is the present weather. There's a little symbol right here that tells you the present weather. And if it's raining or snowing, that will tell me that it's probably really humid out. There is a list of all of the present weather symbols down below this little key. There's rain, there's hail, there's freezing rain, there's drizzle, which is like a little bit of rain, right? And so all of those things tell you that it's probably pretty humid outside. Thunderstorms, rain showers, snow showers, fog, sleet, all of those things are going to tell you that it's probably pretty humid out. The only two that are not usually telling you that it's very humid out, one would be this one, which is haze. That doesn't usually mean it's very humid. And then the other one is smog. Those two things are really more related to pollution. And so that really doesn't tell you that it's very humid out. But the other ones, if you see those little symbols, you can bet that it's probably more humid than not. All right, we have 4 little checks for your understanding to see how well you understand this. Actually, 3 checks for your understanding, 3 more questions. What is the dew point temperature at this station? And what is the relative humidity? All right, hopefully you got that right. The dew point, remember, is this number down here. You don't have to remember this. You don't have to memorize it. Just look at your reference tables, right? So you know what's going to be down here in the lower left-hand corner. So that is your dew point temperature. And then the relative humidity, because these two temperatures are pretty close to one another, then I know it's probably a pretty high relative humidity. Also, it's 100% cloud cover, right? Remember, the clouds can tell you that it's really humid. And also this little symbol means thunderstorms. Thunderstorms. And so if we have a thunderstorm, then it's probably pretty humid. And so the humidity is going to be closer to 95%, not 55%. All right, let's try another one. All right, this time we're going the opposite way around. The temperature is 55 degrees Fahrenheit, and the dew point temperature is 50 degrees Fahrenheit. On the station model at the left, record this information in the proper format. Okay, hopefully you got that right. Remember, temperature is in the upper left, and the dew point is in the lower left. So your temperature should have been up here, and your dew point should have been down here. And remember, there are no units on a station model. So if you put 55, or if you said that there should be a degrees Fahrenheit here, that's wrong because we don't put units here on this station model. We're trying to make these little station models as tiny, as simple as we possibly can. And by putting units there, it just complicates things. That's why we don't put the units on them. All right, one more question. What is the relative humidity and dew point temperature for this station? Okay, hopefully you got that right. We know that the relative humidity has to be low for a couple of reasons. First of all, there's no cloud cover, right? It's 0% clouds, so it's probably a pretty dry day. Also, there's no rain or snow or anything happening here, so it's probably pretty low. And biggest hint of all, these two numbers, your temp and your dew point, are pretty far apart. They're not very close together, so that means it's probably low relative humidity or really dry out. And then the dew point temperature, remember, is the one in the lower left and not this one up here. This one over here on the right, this is your air pressure number. And then this last number, this little number 9, is something we didn't talk about. This is the visibility. Okay, that's also in your reference tables. All right, nice job. So now go ahead and try those practice problems.